Right, so now I want to demonstrate synthetic division for you guys. I'm going to also solve this problem using long division just so you can see, you can compare the two, and you can get a better idea of what shortcuts we're taking with synthetic division, where you can see more of the details with long division. And then I'm going to hopefully work a second example, as long as this video doesn't go too long, with a different division problem. So with this one, so we want to divide 4x cubed minus 2x squared plus x plus 5 by x minus 2. Now, synthetic division is just a shorthand for long division. It's just a shorter way to write it. Synthetic division, by the way, can only be used when what you're dividing by has the form x minus c. So it's got to be x plus a number or x minus a number. So in this case, if we think of synthetic division as we're always dividing by something of the form x minus c, in this case, c is 2. Here. So in the synthetic division, in this shorthand, we put that value 2 in the box. So the 2 here is representing the x minus 2 that we're trying to divide by. We only write this value here. Next to the 2, we write the coefficients of the numerator here. So 4x cubed minus 2x squared plus 1x plus 5. We write only the coefficients. Here this is representing your coefficient of x cubed and your coefficient of x squared and x, and then your constant term. All right, now you skip a line, draw a line here. Bring this first value straight down. So you just bring this 4 down here. And now we multiply. So 2 times 4 is 8, and then we add these numbers. That's something that's different from long division. In long division, you subtract each line from what's above. In synthetic division, we add. So negative 2 plus 8, that's positive 6. And then we just repeat the process till we get to the end here. So we would do 2 times 6, so that's 12. Add these numbers, so that's 13. And then 13 times 2, that's 26. And then add these numbers, so that's 31. The last value here is going to be the remainder. If you divide by something of the form x minus c, so degree 1, the remainder's got to have a lower degree. So if it's lower than degree 1, that's going to be degree 0, so it's always going to be a constant term as your remainder. So it's just the number that's in the box, that's your remainder. And so based on what's written here, what we can say is that when you divide 4x cubed, blah, 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 by x minus 2, the quotient is given by what's here. So the quotient q of x is 4. Okay, so now what power of x? I'm sorry, I know there's a bit of a glare there. Well, if we have a degree 3 polynomial, we divide by x to the first, then the result is going to be 1 degree lower, so x squared. And that's the way it always is, again, with synthetic division. If you're always dividing by degree 1 polynomial, which you will be if you're doing synthetic, then the degree of the quotient is going to be 1 less than what you started with. So I look up here, I see x cubed, so my quotient is going to start with a squared term. 4x squared, positive 6x to the first, 13 for the constant term. And the remainder is 31. Okay, so there's our result using the synthetic division. Now, just to prove to you that this process is valid, I wanted to work it out using the method that you've already studied, which is long division. So we're dividing x minus 2 into 4x cubed minus 2x squared plus x plus 5. Remember that with long division, in each individual step, you just focus on the leading terms. So right now, I just focus on 4x cubed divided by x to the first. I'll jot it down over here. 4x cubed divided by x to the first would be 4x squared. So I'm going to write that above the squared term. And then you multiply. So 4x squared times x minus 2 So 4x squared times x, that'd be 4x cubed. 4x squared times negative 2, that'd be negative 8x squared. And subtract from what's above. So 4x cubed minus 4x cubed, that's gone. Negative 2x squared. Now remember this negative distributes here. So this is actually a positive 8x squared here. So negative 2x squared plus 8x squared would be positive 6x squared. And then these other guys just come down. And then we repeat that process. So now again, divide just leading terms. So 6x squared divided by x to the first right here would give us 6x to the first. And multiply that times the x minus 2. So 6x times x is 6x squared. 6x times negative 2. So that'd be negative 12x. And subtract from what's above. So 6x squared minus 6x squared, that's gone. X, again, distribute the negatives. So this is plus 12x. So 1x plus 12x is 13x plus 5. And then we got to go around one more time. Because these degrees are the same. X to the first, x to the first. So we got to go one more time around. The degree of the remainder, remember, must be lower than the degree of what you're dividing by. So right now, my remainder is potentially degree 1. That's not going to fly if I'm dividing by degree 1. So we got to divide once more. 13x divided by x is just 13, positive 13. And now multiply 13 times x and 13 times negative 2, negative 26, and then subtract from what's above. So 13x minus 13x, that's gone. Positive 5 plus 26 when you distribute the negative. So that's positive 31. So the remainder is 31. And the quotient is 4x squared plus 6x plus 13. Same thing here. But this requires a lot less effort, especially with larger polynomials. What other? Also, you kind of notice the similar steps. If you sort of pinpoint, oh, there's the 8x squared right here. That's that positive 8 that we found right here along the way. That positive 12 is right here. I mean, you can kind of see the same terms reappearing in the work over here that we saw along the way in the work over here. But the synthetic division is just a shorthand. So it's a shorter way to write this out when you happen to be dividing by something of the form x plus a number or x minus a number. Okay, so that's it for that example. I want to show real quick, I'm going to go ahead and put it in this video. If you divide, do one other example. I think this will be enough space. So the example B that I've written over there, if we want to divide x cubed plus x minus 2 by x plus 4, a couple of things to watch out for. One is that notice you're missing a degree. You're missing a power of x here. We jumped from x cubed to x to the first. So just like with long division, I suggested that you create a column for every power of x. You absolutely have to do that with synthetic division. So with long division, it's just like a best practice. It helps you keep things organized. It helps prevent kind of a car crash along the way when you're doing long division. With synthetic division, it's just you have to, if you forget, it's going to mess up your answer, and it's going to be impossible to catch. So there is no x squared, so we need to put a 0 for the coefficient of x squared, plus x minus 2. This shorthand only works if you put a coefficient for every power of x, from your highest one to your lowest one. Also, actually, let me rewrite this denominator. So I was saying that the denominator has to have the form x minus c. So we have to think of this x plus 4 as x minus negative 4. So the c, in this case, is negative 4. And so when I write the synthetic division, I need to put a negative 4 right here. And then the coefficients for the numerator. So 1x cubed, 0 x squared, 1x to the first, and then negative 2 for the constant. These are the coefficients for x cubed, x squared, x to the first, and then your constant. Okay. And now it's just the good old synthetic division that I demonstrated a second ago. Bring the first number down, and then multiply. -4 times 1. Add these numbers. We add with synthetic division. We subtract with long division. Multiply again. -4 times -4, positive 16. Add these numbers. -4 times 17, so that'd be 40 plus 28, so -68. Add these numbers. -70. This value on the end is going to be the remainder. So in this case, x cubed plus x minus 2 divided by x plus 4 is equal to, so the quotient, you start with 1 degree less, so x cubed divided by x, this is going to be 1x squared minus 4x to the first plus 17 is the constant, with the remainder of -70. So remember, one way we could express that is put minus 70 over the denominator, x plus 4. And there we go.